Good day, everybody. Let's look at something new, like a new fundamental thing, and that is the option. And the option is very important element, because why I like the option is because I like the design choice in the Rust language. The fact that the Rust doesn't have the concept of a null value makes it really good. And I don't know this quote. I thought it was the quote of the guy that designed C++, but if I look online, then I found this quote. And then essentially what he says is like, it's his $1 billion mistake, you know, because he was designing this type language and he wants to be safe and everything. And then just out of ease, he introduced this null, and it causes all kinds of memory problems and everything else. So I'm really glad essentially like the Rust community essentially did not use this or did not implement the null value, but instead essentially it forces us to think about all the branches when we do some cases. Like, so if we execute code in Rust and it could have like a none or a null value, and let's say a non-value return, then we have to think about it. And I think this is like a really good choice. Maybe it feels a bit like, especially when beginning, like forced, but in the end essentially you start really appreciating the fact that Rust like forces us essentially to think about all the branches of execution, if you can call it like this. So option, right? So what is an option? Well, let's start with a very simple example. Let's create a vector, and of course we like the meaning of life, so we do like 42, and we will put in, let's say, 10 values, like for sake of discussion, right? And so first of all, let's see if we're still sane and the universe still behaves as we hope it behaves. So let's print this function out, and we hope to see if we execute this like 10 of the 42. So now if you want to get a value, right, from the v, then let's call this the inner value because it will return a sum. Then we do v get, and then we take, for example, the fifth element, right? And this will return, if we print this out, this will return a sum 42, right? So let's execute this and exactly get the sum 42. So this is really nice, right? So because if we would now go take the 11th, right, then, or even the 10th, right, because it's like out of bounds already, then we get essentially, as you can see, a non-value return. So how are we going to use essentially this inner value? So let's just assume we want to like test this inner value, but let's first rename it into sum, because essentially this is going to return a sum. We concluded this already. So now let's say, so if let sum inner value from the sum value, then we start printing, for example, print line, yes. Yeah, we found essentially the value of life, right? So if we execute this, then we say none, right? And then it doesn't print anything, right? Because it's a none. But now, if we use something that's inside the bounds of the function, then it says, yeah, we have it. So here, for example, we already see a very explicit way that we cannot access the sum value unless we do something like unwrap it, essentially. Right? So to get essentially to the inner value. So let's look at the documentation and everything that you can do with it, right? Because that's some really nice stuff. So are there other ways essentially to get to this value, right? So we now, what I like to use in production code sometimes, right? Sometimes you know already, for example, that this sum is going to be something, right? So it's not a none. And then of course you can already, like for example, use these functions, which are really handy. So sum is none, right? That this can help you essentially to find to check if it has a value, and then the rest of the code essentially you can use to unwrap it essentially. So to give you an example of this is, for example, here, if you would rewrite this function, then we could say if sum is none, we is none, then we print yeah, right? Yeah, whoops, and then we say no meaning of life yet in this COVID situation, right? COVID situation. So, okay, but now, you know, so for example, if we would now say, for example, a return here after this, then, so here we know some, you know, has something, right? So so if we now want to access that value, right, we can of course do a destructuring like this, and we can say let sum inner is sum. But now, if we try to do this, then we get an error, right? Because essentially, this is not what they call this refutable pattern, right? So essentially, we try to destructure this value, but it could contain other values, right? So this doesn't work essentially. So we have to really explicitly think now about all these branches. So for example, what we could do, for example, is use a match. Right, so this is like so you say now okay, you want to match the inner value, like the sum value, and we expect now a sum again like an inner value, and we want to do something with this inner value, or if it's none, then we say we want to do like the 0, and now we could say we make it that inner is just to make sure, and we get a little error here, and it says okay, yeah, because I get it out of the thing is a borrowed value, so it requires a borrowed value, and now it says it's not used. So this is a way essentially to get it, right? So now if we would print like this, then again get the inner value out. So let's execute this, and again we have the 42. But this is already like very verbose, right? Because we already know, for example, it is none. So what I like to do then in many cases is that I remove this, and then I just say okay, sum, and then I just unwrap it, right? And this is like the easiest way to do it. So let me know this unwrap, and again we can essentially, do I still have that the inner print? Okay, I still have the inner value here. So when I execute this, then again we have the things. But of course we can also like, but now if it's like a none, yeah, so we change it back to a none and we execute it, then no meaning of life yet, and then it's true. But suppose we don't want to do this, right, and we want to just use a default, that's also very nice, then we can just replace all that stuff with unwrap or, and then we execute a 0, and of course it has to be a borrowed one because we get it out of there. And now if we print it, then hop, we get a 0, and if we try it into 9, then and we execute it, then we get a 42 again, right? There is another thing, there's also, you have to be a bit aware of using sum, that's like the take. I don't know if we can find it. Here we have it. So this takes a value out of the option, leaving a none in its place, right? So this requires us to have a mutable, because now, of course, we need to manipulate it, because maybe you want to register that you took something out of it. And now you can say, okay, then we take the value out of it. But if you again look at the definition of take, you see it returns an option, right? So it's either it takes something, or it replaces or it's none or sum, but it always leaves a none in sum, right? So if we execute this, then again we get sum 42, and if we get like 10, so we're out of scope essentially, then we get 2 nones, right? But this is interesting, right? So it's interesting to see how you can use all these methods. What I also sometimes like to do is you get all these functions like map and filter and everything like this, which normally work on iterators, but they now work essentially on the inner value again, right? So if we just make this 9 again, so, or let's say 5, doesn't matter, we execute it and we can see we still have the sums. You can also now use like map, for example, and now I can say take that inner value, right, and just multiply it by 2. So now we have twice the meaning of life, and now if we execute we see sum 84. And the same we can do essentially with filter, right? So read this documentation because like we have a lot of functions, also the expect. Yeah, this can be very happy, right? So especially if you want to unwrap the value, then you can also use an expect. And so you can also do like if some unwrap or expect, and you can say I expected the meaning of life. I can say to find the meaning of life in the details of Rust language. Then again, essentially this will return the inner value. Sorry about that, inner value. So there's a lot of stuff you can do essentially with an option. It also has this and or and all other kind of things that essentially all work on this inner value, right? And that really makes it like easy essentially to avoid using these null values, and essentially really makes you think explicitly on how to work with all the return values of your system, right? So I hope you enjoyed this, and let me know if what you think about my explanations, and if you would like to have another subject covered on the Rust fundamentals. I like making these videos. So have a nice day, week, life, and we will talk to you soon. Bye bye.